Yes, the recording has started now. Let me share my screen quickly. Okay. Can you guys see my screen now?
Yeah.
Whiteboard? Okay.
Yes.
Yeah.
Are you okay? Yeah. All right. So I will not repeat all that we have learned so far, but I will just quickly touch upon what we learned additionally yesterday. So we have learned about all the shapes and all. Then we talked about the composite shapes, and you guys did some sums around that also. Okay.
Mm-hmm.
Now, yesterday we tried to touch upon the basic concepts of solids. What is a solid? This is a solid. This is a solid. This is a solid.
Mm-hmm.
This is a solid. What we were knowing before or doing before were these shapes: rectangles, squares, and circles, rhombus. Those are not solid. Those are called two-dimensional shapes, meaning it has length, it has width. Okay.
Okay.
If you are looking at rectangle, you know this is length, this is width. If you are looking at come on. If you are looking at circle, then also you're not looking at length and width here, but again, this is something that can be drawn on a piece of paper. Okay.
Okay.
Now, when you look at solid, it has length and width, but it cannot be drawn on a piece of paper. It has because it has height also.
Okay.
If you guys remember or if you guys have heard about this term, people say 3D printing, right?
Yeah, yeah, yeah. I think I might have heard of it before.
Yeah. So when we say printing, if I print a piece of paper, right? I write something on the piece of paper and print it. That is normal printing. That is called two-dimensional printing because that is printing on a A4 sheet, which has a length and width. Okay.
Okay.
But when you say 3D printing, what actually it means is you are creating the solid object by printing. They will print one layer, then they'll print another layer, then print another layer, and then that builds the shape. Okay.
Okay.
That is why it's called 3D. It has three dimension, length and width, and then height also. Okay.
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 So that is where the objects that we start dealing with. This is called a cylinder
Okay.
or a right cylinder. This is called something like a matchbox. Yeah.
Okay.
It is called a cuboid. So cuboid is nothing but a rectangle. You are putting another rectangle, another rectangle, another rectangle, another rectangle. You keep on putting rectangle after rectangle. See, if this was just one page, that would have been like this. I put so many pages on the top of that, right? If you go to Costco, you go for buying that A4 sheet, you will find a bundle which is this thick, which probably has thousands of pages because there's so many rectangles put one after another of the same size. That is how
Mm,
the 3D objects are made. Okay.
okay.
So here also, if you look at a cylinder, this is circle, other circle, other circle, other circle. So many circles kept one after another. And that is how it gives it the shape of a cylinder. Okay.
Okay.
Something similar to this guy. Okay. Here, if you see, this is a circle. There are so many circles kept one after another. And this has made the cylinder. Okay. So in case of solid, let me take a step back. If I'm talking about any shape on a sheet of on a piece of paper, I'm talking about area. When I'm talking about this, so many areas one after another that makes it a volume. This is a volume, meaning this is the total space that it needs. If let's say somebody like me, let's say 50 people like me, can they fit in this room? Probably not,
Mm-hmm.
because the volume that I need, the space that I need for standing in this room, that I need. Okay. I mean, if I have to fit in this room, that much space has to be there. If second person has to come, the remaining space that is there after I have occupied the space, that person also has to have enough space for him to to fit in. If the third person comes, whatever is the remaining space, that person should have enough space in the remaining space for him to fit in. Right, right.
Mm-hmm.
That is how you
Yeah.
see. No, we need enough space in this room. Let's say you are organizing a party with 100 people coming for that. You will not be able to do that in a small place because everybody needs some volume. Okay,
Yeah.
and that's place that venue for your party has to have enough volume to accommodate that many people. Okay, so that is
Yes.
that is how you relate that with the volume. Okay,
Mm-hmm.
so when we talk about any three-dimensional shape or any solid object, we talk about volume, meaning how much space that this guy needs. Okay, or if you look at this cylinder, this is nothing but like a container, right? We have a lot of utensils at home which look like this, right?
Mm-hmm.
What is the volume of that guy? We say, okay, how much water or milk it can contain or hold. Yeah, that is
Mm-hmm.
the volume. So if I am talking about a small cylinder, okay, this will contain less milk. If I'm talking about a bigger container, it can hold more milk. So that difference in the volume of milk is depending on the volume of that container. Yeah.
Yeah.
So that is why when we talk about solid shapes, meaning something which has length, width, and height, that is called a solid shape, which has three dimensions to it. So the key, some of the basic shapes that we'll talk about will be a cylinder, a cuboid, which is made of rectangle. Okay, so there's so many rectangles. Like here, it is made of circles. It is made of rectangles. So it has length. This is width, and this is the height. Okay.
Okay.
Here you have this area, and then this is the height. Okay. Here you don't have length and width. You have the area, right? Based on the radius,
Mm-hmm.
right? Now there is another shape that you will keep playing with. That will be called cube. Cube is nothing but something similar to the cuboid only, but here the base is a square. Okay.
Okay.
This is the length, and interestingly height is also same as the length. Okay, so you can say this is all our length. If somebody says a cube of 5 centimeter side, meaning length is 5 centimeter, width is 5 centimeter, and height is also 5 centimeter. Cube means everything are the same, meaning all the dimensions are same. So it's a square extended in the vertical direction, and also it's only extended to the same side, length of the the side actually. So this is length, this is width, and this is height. Here length, width, and height all are same. That is why it is called cube.
Okay.
And I was explaining this to Mitran yesterday. So if you guys have played with ice cubes, it is supposed to be a piece of ice which looks more like a square, 1 centimeter in length, 1 centimeter in width, and 1 centimeter in height. That is how it is called ice cubes, 1 centimeter cube. Okay.
Okay.
Arna, are you with me?
Hello?
Yeah, Arna, can you follow me?
Yeah, I am.
Okay, okay. So, so this is what we were learning yesterday. There are three basic shapes with which we are starting for solid shapes. Okay. So there are two things that we need to know. One is the volume, meaning the space that it needs, and second is the surface area.
Okay.
Let's say this is a solid shape. Okay, this is my phone, which is a solid shape, solid object. I don't like the color of my phone. Let's say I want to color it green.
Okay.
What will I color? Surface area or the volume?
Surface area.
Yeah. If I want to keep this phone in a closet and I want to find out whether this will fit in the closet or not, What would I need to know? Volume or surface area?
Volume.
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 Yep. So I'm asking very stupid questions, but again, just to relate, okay? Because all that we learn in math, there's nothing hypothetical. You can literally relate, okay? If if let's say I have to keep this water bottle somewhere, okay, on a surface, okay, can I keep it on this guy, on the top of this guy?
You can.
That needs a lot of skill. I'm saying as a normal person, can I keep it on this one?
No, you have to balance it.
Yeah. Now I'm saying without showing any skill. If what will I look for? I'll say, okay, what is the base looking like? Oh, it's a circle. So I can keep it on a surface which has area more than the area of this circle. Yeah.
Yeah.
Meaning, let's say if I have to stand on something, right? If I have to stand on the edge of a wall, that edge should be broad enough to 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 for me to be able to put my feet on it, right? Meaning my feet's surface area should be smaller than the edge of the wall, otherwise I'll fall, right?
Yeah.
So that is the significance of these things, right? People get confused between surface area, volume, and all. I'm just trying to relate that. Okay, let's say if I have to keep this object somewhere, what will I look for? I'll say, okay, fine, I can keep it with the base. So this is the base, which is nothing but like a circle. And what is the area of the circle? Meaning how much space that this area needs. Okay, and I can keep it on any area which is bigger than this. Yeah,
Yeah.
very easy. It's like when, let's say, when we look at no small babies, right? Baby can the parents can hold the baby, right? Because the parents have more surface area, more strength, yeah, more volume. Babies have less surface area, they are small, less weight.
I can't really hear you that well. It's like glitchy.
Can you hear me okay now?
It's like blurry or something.
Okay, how about you, Mitran? Can you hear me okay?
Yeah, I can hear you okay.
Okay, so Arna, what we can do is, let's try for a minute or two. If you still face any problem, I would request you to disconnect and join back again, because for last few days I'm seeing the network has been pretty patchy for me and for some of my students also. Yeah.
Oh,
So are you able to hear me okay now? Somewhat manageable?
yeah, it's like a little better.
Okay, okay. I'll try being a little louder also if that helps. Yeah.
Okay.
So what I was
Okay.
trying to relate was that, okay, if you're looking, let's look at a baby, 6 months old baby. Okay.
Hmm.
Can the parents hold the baby? Yes, they can, right? Because they have bigger surface area to keep the baby on, right? I mean,
Yeah.
in the lap, right? To hold in the arms or in the lap, right? They have more
Hmm.
surface area, more than how much space that baby needs.
Yeah.
Reverse the story. Can the baby hold the parents?
No.
No, right? Because babies don't have enough surface area to make the parents sit in the lap, right?
Hmm.
So that is the relevance of the surface area. Okay. When we talk about a surface area, let's say I want to color this room. What I would want to color? Volume or the surface area? I want to paint this room. Okay.
Okay.
I don't like the color of this room. What would I color? The surface area of the room or the volume of the room?
Surface area.
Yeah. So that is how we have to relate. Surface area means the area of the surface, on the surface. Here, if I'm looking at this bottle, if I don't like the color of this bottle, I'll color the surface area of the bottle. I want to make it yellow, let's say. Okay, I'll color this part. I'll color this part. I'll color this part. That will cover the surface area because that is what is visible. So surface area is something that is visible. Volume is volume just gives you a view of the shape, but you would know, okay, this has bigger volume or more volume or less volume, but what is visible is apparently is your surface area. right? Okay, now let's do some formulas quickly, and then we'll try doing some sums. No, now let's focus on cylinder for now. So cylinder is nothing but a circle, yeah, and this
Mm-hmm.
is my radius. If I have to find the volume of the cylinder, what I have to do, I have to find the area of this circle and then extend that area to the height. Meaning, because we are putting one circle, another circle, another circle, another circle, right? That means
Mm-hmm.
this is the area that of the circle. What is the
Mm-hmm.
area of a circle?
Area of a circle is pi times r squared.
Yep. Now, if I have to find the volume of the cylinder, what will I do? I will find out the area of the circle or the cross section and multiply this with the height. Okay. So
Okay.
my volume of a cylinder is pi, uh, come on, pi r square h. Here, r in the case of cylinder, it has a radius because
Okay.
it is circular in nature. Pi r square gives me the area of this cross section. I call it. Okay, when I cut it, like vertically, I get a circle. So that area pi r square and multiply that with h. That is my volume. So if the volume is if the height is less, h is less, volume is less. H is more, volume is more. H is even more, volume is even more. Yeah, yeah.
Okay. Yeah.
For the same radius, meaning for the same circle here, if my height is this much, that means volume is less. It can hold only this much water. If for the same radius, if this is a taller bottle, it can hold more water actually, or milk, whatever I want to keep it, right?
Yeah.
So that is how the volume is pi r square h. Any confusion so far?
No confusion.
Arna, are you with me?
Yeah, I'm listening to you.
Okay. I mean, you're able to follow or relate, right?
Yeah, I'm just writing everything down.
Okay. So volume is pi r square h. Now comes an interesting question. Okay.
Okay.
Now, if I ask you guys, what is the surface area of the cylinder? Okay, which has a radius of r and height h. So this is something that I would want you to guys think. Okay, I am not in a hurry to explain or not do the formula for cuboid and cube also. I want to spend some quality time on this one. I want you guys to think and tell me, if you have to find out the surface area of the cylinder, how will you find it? Go step by step. Think like a baby, okay? You'll find the answer.
You do the I think um uh I think um
I'll give you guys one clue.
Can you repeat the question?
Okay, now I'm saying this is my cylinder, okay?
Yeah.
mhm,
Okay, which has radius as r, meaning here the radius is r, here also the radius is r. It's a
Yeah.
symmetrical cylinder. And the height is h. If you have to find out the surface area of the cylinder, how will you find it?
Wait, what was the height again?
H.
I know, but what's the? Is there a number?
No, I'm not giving a number. I'm just trying to derive the formula for surface area of a cylinder. So radius is r. R could be 1, could be 5, doesn't matter. And height is h. H could be 5, it could be 25, whatever it is. I'm asking you guys, can you think and tell me what will be the surface area of the cylinder? Can you guys see it? See, I told you guys, okay, the answer to this question lies in the way you think. If you think like a baby, you'll be able to find it. What did I do? I used a piece of paper, I made it like a cylinder. Yeah.
Mm-hmm.
And I'm asking you guys to find out the surface area. Okay. Let, let me
Is it the outside of the cylinder?
now surface area will be surface area, whatever you can see. It'll be this area. Okay. So let me break it down further. Okay. So if I'm talking about the surface area of the cylinder,
Mm-hmm.
I'm talking about the whole curve area of the curve. Okay. I'm talking about this area and I'm talking about this area also. I'm saying it's a solid cylinder. Okay. I'm not talking about the area inside and all. Okay. I'm just saying it's a solid cylinder like a log of wood, which is in the form of a cylinder. So this area and this area. Okay. And then this
Okay.
area.
Okay. I think I probably might know.
Okay. Try it. Okay. I want you to try.
Um, do you have to find the area of the two circles on top of each other and then find the perimeter?
Yes, you are moving in the right direction. So first of all, you will find out the easy things. Okay, so you will find out the area of this top no, and area of this circle. Okay, that gives you the coverage, right? That's what I was doing, right? I was giving you guys a clue. So this area you have to find, and this area you have to find. Okay,
Mm-hmm.
so area of a circle is what? Pi r square.
Mm-hmm.
Pi r square. Since you're talking about this area and this area, both are same, right? It's symmetric. So it will be 2 pi r square. Yeah.
Mm-hmm.
So this is 1 pi r square and this is 1 pi r square. So 2 times pi r square. That has only given you the surface area of the top and the bottom. Still haven't got the surface area of this curve. Yeah.
Yeah.
How will you get the surface area of this curve? There's one more clue. Look at this side. Okay. What I'm doing now,
You're
Okay.
rolling it up.
I opened it. Now it is what? It is like a rectangle.
Yeah.
Mm.
Yeah. My curve surface, right? This one. Yeah. If
Yeah.
I opened it around the perimeter of the circle. Yeah. So whatever was the perimeter here, that opened up to become one side of the rectangle.
Okay.
Okay. Let me make it little clear. This is my center. This area and this area. This is h height. You found this area, okay, and this area. This is pi r square, and this is also pi r square. Okay.
Mm-hmm.
What you don't know is this this curve portion of it. Yeah.
Okay.
This curve portion of it, right?
Mm-hmm.
What did I do? Look at this circle. What is the perimeter? This is the boundary. Yeah.
Mm-hmm.
What did I do? I opened it.
Yes.
So now imagine when it was a cylinder, this was a curved surface. I opened it to make it like a rectangle now. This is my total curved surface, if you can
Mm-hmm.
see it.
Yeah.
This is the length, let's say this is the length and this is the width. What is the width? This is nothing but the height of the cylinder, okay? This here to here is the height of the cylinder, okay?
Okay.
And what is the width? This width is what was the perimeter. See, this perimeter became the one side. What is the perimeter here? 2 pi r.
Okay.
Again, look at it carefully, okay? So You guys can see me, right? What I'm doing.
Yes.
So see, this was my cylinder. Okay, this is the area pi r square. This is the area pi r square. Okay, what I'm trying to find out is this total surface, the curved surface. Okay, what did I do? I opened it up. This is my curved surface actually. Okay, which was folded like a circle.
Okay.
Now this is a rectangle actually, and this is my height. See, this was my height, right? And this was the perimeter of the circle or circumference of the circle. What is the circumference? 2 pi r, right?
Hmm.
So this 2 pi r became one side of the rectangle, and this is my height.
Okay.
Am I making sense so far?
Yeah.
Yeah, Arna, am I?
Yeah.
No, and again, trust me, it is all about how you visualize this. Okay, so I'm okay explaining this 3 more times, 4 more times, but I would not ask you guys to say yes if you have not followed me 100%. I want to hear that excitement. Oh, yeah, this one we did not notice. If I hear that, that makes me believe that yes, you guys are following me.
Okay.
See, this is the circle. Okay, this is the cylinder. Okay, I found this area pi r square. I found this area pi r square. What I'm trying to find is the curved surface. What is this curved surface all about? This is the perimeter. I just cut it open. This perimeter, this is the perimeter of the circle of the cylinder. That is 2 pi r, which has a radius of r. So this became one side. This is a rectangle now, with one side as 2 pi r, the circumference or the perimeter, and second side as the height, because this is what it is, the height of the cylinder. I have cut it open. The height remains the same. Only thing that happened was this 2 pi r, the perimeter of the circumference, got wide open to make this as a rectangle. And rectangle's area, I'm trying to find out the area of this thing, which is more like a rectangle now. Length times width. Length is this, width is the perimeter that made this side 2 pi r.
Okay.
Yeah. So the total surface area is this pi r square plus pi r square. So I can say 2 pi r square. Okay. One apple plus one more apple, two apple, plus this 2 pi r into h. Now
Okay.
you can take something common. You see 2 pi and 1 r being common. Here you have 2 pi r and h. So if you take 2 pi r common, you get a r extra here, plus here you get these three out, you get an h extra here. So 2 pi r into r plus h. That is the formula for surface area of a cylinder. If you want to remember it, up to you. Otherwise, you remember the concept. How did we derive it? Okay.
Okay.
Then you'll be able to play with it. So if I summarize this, okay, see, that is why, I mean, it's very easy for me to tell you guys the formula, okay. The volume of cylinder is pi r square h, and the i- surface area equals to 2 pi r into r plus h. Why did I not do it in a simple way? Because I wanted you guys to understand how it is.
Okay.
Yeah.
Oh yeah. Okay.
So I kind of said, okay, fine. This is one surface area. This is one surface area. These are circles. I know it. Pi r square, pi r square. Done. Now the biggest question is what happens to the curved surface. So when I cut it open, this becomes a rectangle. And rectangle, the one side of the rectangle is the perimeter or the circumference of the circle, which is 2 pi r. So 2 pi r, and this is the height anyways, so 2 pi r into h. So this is how it became 2 pi r square plus pi r square plus pi r is plus whatever. Sorry. So this curved surface became circumference as in 2 pi r and
Okay.
multiplied by the height, because this is a rectangle now. This is 2 pi r and this is the height. So
Okay.
the
Okay.
curved surface became this much. So we added this with the area that we had found for this part and this part. So 2 pi r square plus 2 pi r h. This is my total surface area. Okay. So you're
There.
taking common things out, 2 pi r out. So this becomes r plus here you take these three things out. So you have h. So this is the formula. Up to you if you want to remember this formula or if you want to remember the concepts. Okay.
Okay.
So this deals with the cylinder. Any questions so far with respect to the understanding of the concept? And be
No.
honest with me. I mean, I'm perfectly fine explaining this one more time.
I'm
Arna?
now. I don't think we're struggling. Oh,
I don't. I feel like it's like not bad because we're kind of learning the same thing in school too.
Okay, wonderful. So it's clear, right? You'll
Yeah.
Let's say in the school, if somebody says, okay, what is the surface area of a cylinder and how it is derived, you should be able to explain that how it is derived. You can take a piece of paper and
Okay.
you can explain that to people.
Okay.
Okay,
okay.
because concept is something that lasts with you for the longer time. If you memorize the formula, you'll remember it for the exam and you might forget it after the exam. Yeah.
Yeah.
So always focus on concepts. Question yourself, question your teacher. Okay, you told me this is the formula, but how did that come into play? It's math. It's not AP US where somebody tells you that this is the this is the history of US. Yeah,
Okay.
this is maths. All right. So this is the volume and surface area of cylinder. That's what we learned. Now let's look at volume and surface area of a. I'm just thinking. Shall I? Okay. Let's do it for. Let's do the volume and surface area for a cube. Okay. That'll be fast and easy. Okay. I don't want to stress you guys by teaching so many things and then you end up forgetting it. Okay. Now look at this cube. Why it is called cube? Because length, width, and height all are same.
Mm-hmm.
Have you guys seen a dice?
Yeah.
Have you played Ludo?
Yeah. I did.
How about you, Arna?
Wait. What? What did
Have
I
you
say? What?
have you seen a dice?
Yeah.
Have you played Ludo before?
Yeah.
Yeah. So this cube is nothing but a type of a dice actually. Okay. Yeah. Where
Yes.
the length, width, and height all are of same size. Okay. So let's say if the length is 2 centimeter, your width is also 2 centimeter, and height is also 2 centimeter. So far so good.
Yes.
I'll keep on checking with you guys. Okay. I'll keep on asking stupid questions just to assure myself that whatever I'm teaching you guys are with me. Okay. Yeah.
Okay.
Okay.
So, and you guys can tell your friends that I have got a very stupid teacher who keeps asking very stupid questions. That's fine. Okay. Now, now again, see this is a bit of visualization. Okay. Imagine if you remember the dice. Okay, with that you would have used for playing Ludo. How many numbers do you see? Each side has some numbers, right? Some
Yeah.
dots. How many sides do you see in a dice?
6.
Six, yeah. That's what we see, right? 1 to 6. That's the number that we see. So a cube, as I said, a cube is nothing but like a dice. It also has 6 sides. Okay.
Mm-hmm.
Now 6 sides, and all the sides are same actually, isn't it?
Mm-hmm.
In terms of area, because your length and width are same. So this area here also is the same, right? This area is same as this area. Yeah.
Mm-hmm.
All the area is actually same. Let's say if I'm talking about a cube, okay. of 2 centimeters. Okay, 2 centimeters as each side.
Okay.
Yeah,
Yes.
all the sides are like squares. Yeah, because they have length as 2 centimeter, width as 2 centimeter, length as 2 centimeter, width as 2 centimeter, right?
Mm-hmm.
So actually you're dealing with six six sides or six squares of the same area, because your cube has the property which says length, width and height, everything is same. That means all your sides are same. If you recall, if you find out a dice now and look at it, you will find that every from if you turn around, turn it no in any direction, every side is perfectly matching with other sides actually in terms of area or the dimensions. Am I making sense?
Oh yes.
Arna, am I?
Yeah.
Yeah.
Yeah,
So
you're clear.
that means my surface area of the dice is equal to 6 times of something common. Okay. So if I pick this area, this side, let's say this is length and this is length, this is width. Here, length and width are same, which I'll call as length. Both are length. Height is also length because everything is same. 6 times of one area is length into length.
Okay.
My surface area of a cube is 6 times length square. Length into length is length square.
Okay.
Now, now you again
Okay.
imagine a dice. Your dice has all the sides same. Okay. So to find out the surface area, you have to just find out the area of one side and multiply that by 6. That'll be a total surface area. And here you know this is your length, this is let's say width. Both are same. So you'll say 6 times of length square. That is your total surface area. Am I
Yeah.
making?
Yes.
Okay.
Yeah. Now what is the volume of this guy? So volume is like always take the base, take the area of the base, multiply that by height. So what is the area of my base? This is a square. Area of a base is what? Length into width. Here length and width both are same because it's a cube. So I'll say length into length, length is square. And then I have to multiply that by height, like we did in case of a cylinder, right? We found the area of the base, which was pi r square, and multiplied that with h. That gave me the total volume. Here also, I'm finding out the area of the base, multiply that with the height. So here my height is also length, same length, width, height, everything is same. So my volume is equals to area, which is length square, times the height. Height is also length, same. So volume becomes length cube.
Okay.
Or another way you can relate is if I have a cuboid, meaning this is a rectangle, this is length, this is width, and this is height. So volume of a cuboid would be the area, this area of the base multiplied by the height. So area of the base is length times width times the height, the height. Okay. If
Yeah.
same thing you're doing it for a cube, here also you can say the volume equals to length times width times height. Here your length, width and height all are same. So you will say length in width is also equal to length. So I'll say length. Height is also equal to length. So I'll say length. So here it becomes length cube. Yeah.
Yeah.
So again, I'm doing a recap. Okay. We'll close the class here with the two takeaways or two shapes that we have learned. One is cylinder. Here, the volume is equals to the area of the base, which is pi r square. Multiply that with the height. Okay.
Okay.
This gives the volume of this guy. Surface area of this one is this area, pi r square, and this area,
Okay.
other pi r square, plus this perimeter thing that we broke into a rectangle. This perimeter is 2 pi r. This becomes one side. And when you cut it open, the vertical distance, I mean the total height of this one is the another side of rectangle. So your one side is the circumference, which is open like a side, which is this, and you multiply that with the width of of the rectangle now. So this becomes the formula for surface area, which is 2 pi r square plus 2 pi r h. You can write in the way you want, okay? All
Okay.
right. And then the second thing that we learned was area and volume of a cube.
Okay.
Volume is the base multiplied by height. So base is length times width. In case of cube, length, width, and height all are same. So I'll say length into width. Width is also length into height is also equal to length because that is the property of a cube. All the dimensions are same. So volume is length cube. Surface area, you will recall this like a dice which has 6 sides. All the sides are same in area because all are square. So 6 times area of one side. Area is length times width. Here length and width all are same. So length times
Okay.
width is length.
Okay.
So 6 times length square. Okay.
Mm.
And another thing that we already knew was the volume of a cuboid that we started with. Any shape's volume is if it's a symmetric shape, okay? I mean, unless it goes like this, it'll be difficult, okay? It's a symmetric shape. So you have to always look at find out the area of the base and multiply that with height. Here the height is h, this is length, and this is width. So volume will be area of the base, that is length times width,
Mhm.
and then multiply that with height. Okay. What we have
Okay.
not done so far is the surface area of a cuboid. That we'll do later. I would want to again break it down like the way we broke down the surface area of a cylinder to explain you guys. Okay.
Okay.
So you all know, you both know the volume of a cuboid, volume of a cube, and volume of a cylinder. You also know surface how to derive the surface area of a cube and surface area of a cylinder. But you have not seen how to find out the surface area of a cuboid. That we'll do in the next class. I can still try doing it. It'll be a little stressful for you guys, and you might forget what we have learned so far. Okay.
Okay.
So let me stop presenting, and I'm not
Okay.
I'm not going to do any sums right now because it's going to be based on formula. I will give you guys some sums to do, and let's see if you're able to think and do it. If you struggle, I'm always there. Don't worry about it. Okay. I'm
Okay.
stopping the presentation, stopping the recording right away so that we can talk.